we'll go ahead and get started with our first presentation here. That is going to be what's new in NX 2007-2206 Design CAD topic. Now in this year's NX University sessions, we are covering two versions of the software. We'll be looking at NX 2007 as well as NX 2206. All right, first off with a quick introduction about myself. My name is Michael Pinto. I'm an application engineer here with Swoosh Technologies. I'm also a technical instructor and I do teach the software to customers such as yourself. So a little bit about my background here. I have over 23 years of experience using the Siemens design products. Specifically, I did design products for the aerospace industry and I moved into consumer product goods on the second half of my career. I worked for companies such as Pratt & Whitney and Nike. I do enjoy teaching the software and supporting customers such as yourself in your pursuit of achieving the best possible designs using the Siemens software products. My particular areas of expertise with the NX software are in 3D modeling, advanced surfacing and freeform modeling, model-based definition and PMI, assemblies, drafting, and a newer application inside the software called stage modeling. If you want to reach out to me in the future, if you have any questions after these presentations, feel free. You can send me an email at that email address you can see down below my title. You can also go ahead and take a quick snapshot of that QR code to save my information. If you want to go ahead and open up the camera application on your phone, take a quick snapshot of that. You can save my contact information to your phone. All right, so jumping into a quick overview of our agenda here, we'll be taking a look at three different main categories with this discussion. The first one being fundamentals. The second item we'll look at is going to be the sketch-related topics, and the third will be feature modeling-related enhancements to the software. So jumping into our first topic here, fundamentals, we're going to look at group command enhancements, grouping faces, search enhancements, as well as some measure enhancements, and then we'll finish up with one other topic related to the different logos that you can apply on your parts and visualization preferences you can turn on to show logos on your parts in these shaded views. Okay, jumping into the group command enhancements here, group faces. This was released in version 2007. As you go through this presentation, you will see the top left corner, there is going to be a version added topic up there, and you can see the version of the software the enhancement was made or introduced in the software. So as we go into these different topics, I will be letting you know what version of the NX software or what release that this enhancement was added to the software. So the first item we're going to look at here is the group command enhancements, group faces, and this was released in NX 2007. So Siemens has added the capability to group your faces together by using a group command. This allows users to group a series of faces together for easy selection and interaction with those faces at a later point in time. It's very easy to apply these different groups. All you have to do is open up or create a new group, select the faces, give a descriptive name, and there's an additional setting in the settings panel, and you'll see it's called Apply Group Display Properties. Essentially what this is going to do, it's going to add or give all of those faces the same display characteristics for the group faces, such as color, face edge fonts, etc. here. We also have the capability to add attributes to face groups as well. The face groups can then be carried through body links into another part file, and then the face group attributes can be utilized in things such as PMI notes and somewhere else inside of another part file if you need to do those sorts of things. This also allows for identification of multiple faces that represent a functional feature area of the component. We can define attributes to set a functional face inside the design. We can link through bodies and perform Boolean operations here. We can extract attribute values inside of notes, such as a PMI note in another part file. And it's going to allow you to visualize functional areas with a simple selection on that particular group of faces. Jumping into a quick demo here, we'll take a look at the group command enhancement using faces. So we'll go into the menu format group. We'll create a new group here. We can give that a descriptive name. In this case, we might want to call out some surface coat areas, maybe some faces that have a surface coat finish that's going to be applied to those faces. We can add those group faces together into one group. And we can use some of these different functionalities such as face selection rules to quickly select those faces. In this case, we'll leave it on single face and we'll pick a few different faces on our part. Down in the settings, we can apply a group display properties, and this is going to allow those grouped faces to have the same display properties inside of our part. As you can see, in our groups, over in our part navigator, we now have a group surface coat group, and it has a number of faces in there. There is a total of 7 faces inside of that group. If we go over to our View tab, jump over to our Edit Object Display command, and then put our cursor over that group of faces, you can see now when we interact with the faces, they're treated as a group of faces. If I want to select that group of faces, I can go ahead and just put my cursor over the faces, left mouse button click, and select all of the grouped faces. Next, we'll take a look at reusing some of the group face information and attributes embedded inside a group of faces here inside of another part file. So we do have an LPTB output here. As we go into our wave link or wave interface linker, we're going to begin to link the low pressure turbine blade and the interface LPTB from that part file into our new part file. Down below, we can copy group containing face and then select OK. Once we copy that group of faces over with the wave linking technology inside the software, we now have that over inside of our new part file. We're going to add a new PMI note to that leading edge on that new part. So we'll go ahead and select the leading edge here. We are adding a PMI note to that new part file. Once we do that, we are going to go and reuse a part attribute with the object attribute option here from the wave linked output interface. We can select the target, so I will select the LPTB leading edge linked group here. And once we open up the attribute dialog box here, we can go ahead and use the PMI label attribute with the variable or value set to leading edge there. After we select OK here, it's going to add the words leading edge to my PMI note. There's my leading edge attribute information that is being pulled from the other part file. If I go back into the leading edge face group and go into the properties here and adjust the value, and we add an additional word here, we can type in the word face and then select OK. Now you can see the word face has been added to the end of that PMI note. So you have that associative relationship here between the original part file, the original grouped faces, over into the new part file with the wavelength geometry. We created a PMI note on our part, and then we also referenced an attribute from the grouped faces, and now that is going to be reflected inside that PMI note and updated accordingly. The next item we'll look at here is Search Enhancements, new search window functionality. This was introduced in NX 2007. You can now search commands, customer defaults, preferences, tips from the Discovery Center, and checkmate test as well using this search functionality at the top right corner of the main graphics display. All we have to do is typing a search term here, hit the enter key on our keyboard, and we can go ahead and open up the search window. Once we get the search window opened, and that's going to be on the top of your tabs, go ahead and select the search window, and you'll see we do have some subcategories now that we can go ahead and click on and see items related to the search term that you entered there in the search field. So the search capability is now going to search all commands, customer defaults, preferences, discovery, or the checkmate test inside the software. So some nice enhancements here with the search functionality. Additionally, we can also use operators now with the search functionality. This was introduced in NX 2206. For instance, if we use a space operator, for example, edge space blend, both edge and blend will be searched for, and you'll see that open up that context drop down, and all the items down below will include the words edge and blend. If we use the comma here, edge comma blend, either edge or blend or both items with those items will be returned inside that drop down list. The quotation marks around that term, and for example, open quotation mark, edge blend, close quotation mark, is going to search for the exact term edge blend. Jumping into our demonstration here, we'll take a look at those search enhancements. So search enhancements, new search window. Up in your top right corner, inside that search field, all we have to do is type a term, such as sketch, and hit enter on our keyboard. You'll see that we have some subcategories. So we have all, it's going to search all the different categories for that term. We also have commands, customer defaults, preferences, discovery, and checkmate tests. So we can search among these sub-level categories here. So we'll try and search commands. There's the word sketch or the sketch feature. Once we click on that, it's going to go right into creating the sketch feature. The next thing we'll look at here is the search enhancements, use keywords with operators. So up in our search field, we can go ahead and type a space as the operator, so edge space blend, and down below the results return only items with both terms edge and blend in them. If we backspace that out, and this time we type the comma as the operator, so edge comma space blend, items with both edge or blend in them will be returned inside the drop-down menu there. All right, jumping into our next topic here, measure enhancements, show all alternative measurements. The version that this was added in was NX 2206. So the measure command is now enhanced to show measurements inside the scene dialog as a list, or we can show all the alternative measurements at the same time. To enable this capability, we do have to go into the measure preferences, scene dialogs, alternative measurements. On the layout drop-down menu, we want to choose show all. Once we turn show all on, over on the right-hand preview window, you can see inside the measure dialog box inside the graphics display, we now have the capability to select and quickly select a measurement type inside there by selecting on the corresponding radio button for that measurement type. Once you select that option, it's going to show you the measurement or the alternative measurement inside the graphics display that has been activated here. We also have the capability to add or remove options from that measure dialog very quickly. Also introduced in NX 2206, the measurement options can now be added or removed by using our type drop-down menu over on the right bottom corner. Select on the down arrow, open up the sub-menu, and then go ahead and select on the category that you would want to show for that type of measurement inside that dialog box. Additionally, we also have the capability to create geometry while editing measurements here, also introduced in NX 2206. So we can now create geometry with associative measurements while editing existing associative measurements. Prior to this enhancement, geometry could only be created at the time of measurements creation. Now we can go ahead and create geometry after an associative measurement has been created. If we want to go back in, edit the associative measurement, we can go over to the right-hand side and we can select the Create Geometry button there on the pop-up measure dialog box in the graphics display. Jumping into our demonstration of these items, measure enhancements show all alternative measurements first. We'll go into our measure tool here. We're going to open our measure preferences up, go into the scene dialogs category, go to alternative measurements. On the layout options, we can go ahead and hit the drop down here and choose show all. Once we take our measurement between two items on the part, you can see inside the measure dialog box, we now have the capability to see all the alternative measurement options here. The next item we'll look at is add remove results from the measure dialog box. On the right hand corner, bottom corner, you're going to see a drop down arrow. Go ahead and left mouse button click that, open up the secondary menu here, and then we can go ahead and turn on or off different categories to be displayed on the measure dialog box. Prior to this enhancement, you would have to go into your preference settings and do this individually for each category. Our next topic here, creating geometry while editing measurements. We will take a measurement here on our part. And when you do that, you want to go ahead and save that measurement associatively. So we'll click on the icon here to save an associative measurement of our maximum or our minimum distance. Over on the right, you'll see a circle and a slash or a line. If we click on that icon, it's going to save that geometry. If we edit the measure feature after the fact or after it was created, we can go in very quickly and switch to an alternative measurement and create the geometry and have that generated for the alternative measurement here. So prior to this enhancement, you would not be able to do this, as you had to create that geometry at the time of creation of the measurement the first time. All right, jumping into our next topic here. Enhancements to your decals. We can make the decal stickers visible inside the shaded views. This has been added in version NX 2007 here. You can now view your decals inside your shaded display rendering styles or in drawing views with the shaded display turned on for that particular view. Prior to this enhancement, we were only able to see these types of decals on our parts inside the photorealistic rendering display, but now we can go into our preference settings. We can go into the visualization preferences, rendering styles, shaded object display, show decal stickers setting. Once we toggle this option on, it's going to enable us to see those decals inside of these standard shaded views or these shaded views with edges, as well as on a drawing view, as long as the shaded style is turned on for that drawing view. So jumping into a demonstration of this, as you can see, we do have an NX University logo on our part. We can see it is in a studio rendering mode right now. That's why we can see the logo on the part. If we change our rendering style here to shaded with edges, we lose the logo on the part. If we go into our preferences, visualization preferences, go into the rendering category, styles, shaded object display, and turn on show decal stickers, what that's going to allow us to do is show decal stickers on standard shaded views. Now this is going to be a performance, it's going to use some more CPU processing, so you do get a warning from the software. It tells you that as well. Now that we can have that setting turned on, we can also go into the effects here, and we can toggle this off very quickly. So the show decal stickers option, we can toggle this on and off very quickly if we do not want to see that in our shaded view. Inside of a drawing here, you can also see we can add these shaded views to our drawing views. As long as the shaded appearance is turned on, you can see the logo on the part inside the shaded view. Jumping to our next topic here, the sketch topic, we'll take a look at half dimension for diameter, solver, new midpoint finding capabilities, sketch pattern enhancements, improved handling of endpoint conditions, as well as a new mechanism mode that was introduced inside the sketch solver. The first thing we'll look at here is the half dimensions for your diameters. The version that this was added was in NX 2007. So a new capability inside of our sketch is the ability to create your half diameter dimensions for your sketches that define your cylindrical parts. What this means is if I go ahead and select the y-axis, in this case, or the center line inside my sketch, and then click the item I want to measure over from that center line, this is going to give me an option to convert that to a half diameter. Once I create this half diameter or first half diameter dimension inside the sketch, the software recognizes that this is a part that is revolved around the given axis, in this case the y-axis. So going forward after that point, I've established that criteria. If I create additional dimensions, first by picking on that same y-axis over to another item, it's going to automatically create the half diameter type dimension for me. So all we have to do is create the dimension, right click on the dimension, and on the context menu we can choose convert to half diameter. Jumping into a demonstration of this, you will see we have the same part file here. And we're going to go ahead and enter our sketch. As you can see, we do have the select the center line or the y-axis first. Once we pick that, we can go ahead and pick the item to dimension 2. We can select that dimension and drag that up and place that inside of our sketch. After we've placed that dimension, we can right click on it, and then we can choose on the context menu, convert to half diameter. After we've converted that to a half diameter, going forward at this point inside the design, if I click on the y-axis first or the central axis here of my part of revolution, and then click an item to dimension over to, it's going to give me a half diameter dimension. So after you create that first diameter dimension or half diameter dimension, the sketch understands that anything dimensioned off the y-axis is going to be considered a half diameter type dimension. As you can see going forward, when I create those similar types of dimensions it's giving me the half diameter result. Jumping into our next enhancement here with our sketch solver, we have solver new midpoint finding conditions, and this is introduced in NX 2206. The midpoint finding is now supported by the sketch solver, reducing your sketch creation times here. So previous versions of NX required the user to create a persistent relation for your desired midpoint conditions. Now the solver enhancement removes the need for this extra step. It understands when an endpoint is placed on a midpoint of a line or an arc, and it automatically creates the found midpoint condition. You'll also see in the relation finder settings the new midpoint option. You can go ahead and toggle that on and off. If you want this to be ignored, you can go ahead and just toggle that off and go right back to the way it previously worked. This is both supported for both lines and arcs, auto symmetry for specific cases here. So jumping into our demonstration, we'll take a look at solver new midpoint finding capabilities in the solver. So first we'll start out with an arc here. As we generate that arc, we'll go ahead and create a line now and pick up on the midpoint of the arc. Once we pick up on the midpoint of that arc, the software automatically finds our midpoint relation. If I move the arc, you can see that the midpoint relation is maintained. If I move the curve, the midpoint relation is also maintained there. We can also do that with lines. Go ahead and create a secondary line at the midpoint of the first line, and we've created that direct midpoint relation condition here. Additionally, we'll try that with a rectangle next. And then we'll create a bisecting line between the two sides of the rectangle. Once we pick the midpoints on either one of those sides, the software is going to find the midpoint relation. We can quickly add a dimension here and make an adjustment to that dimension. And you can see the relationship with that midpoint finding is going to be maintained between our rectangular outside edges and our interior horizontal curve. If you do need to relax those conditions, just click on the line, go ahead and click on the actual relation, relax those conditions, and you can go ahead and move the curve away from the midpoint condition. All right, jumping into our next topic here, sketch, functional sketch patterning enhancements inside the solver, released in NX 2007 here. Our pattern creation inside the sketch is now more powerful with new dragging functionality and a higher quality to provide editing flexibility inside your sketch environment. Our sketch pattern improvements allow for more robust modifications and updates to our sketches. We can edit the pattern seed shape and the patterning distance simultaneously while dragging. This also allows for sketch pattern quality improvements, which is going to make your sketch much more robust. So jumping into a quick demonstration here, sketch pattern improvements. Here you can see we do have a sketch already defined inside this part. We'll go ahead and activate that sketch. And we're going to create a pattern. So we'll activate the pattern command here inside the sketch solver. We will select our curves that we would like to add to the pattern or pattern. Inside the dialog box, we do need to prescribe our pattern parameters here. So this is going to be a linear pattern. We need to select our linear object here, and we have a count of 10. Once we create our pattern, you can see we can now make some edits to our design, and you can see the pattern is going to update accordingly. Whether that's a physical dimensional change, or we go ahead and move the position of that sketch or those sketch curves inside the sketch solver here, the pattern will update accordingly. Okay, next we'll take a look at an additional sketch improvement here. Improved handling of your curve endpoint conditions, also introduced in NX 2206. This new option is going to allow and facilitate easier modifications inside of your sketches. Inside the new sketcher, those curve endpoints can tend to be sticky, which would result in difficulty when you need to make modifications to move your curves apart from one another. Some new enhancements inside the solver will solve this problem. So this is going to allow us to split common vertices from touching curved loops. Gives you the ability to separate offset loops if that offset becomes 0. Also, the ability to separate offset loops that are touching. It gives the relation-based vertex splitting coincident conditions here. Also, the ability to split mirrored curves that touch. Additionally, splitting is now allowed where many curves share a vertex. Taking a look at a quick demonstration here, we'll take a look at the improved handling of curve endpoint conditions inside the sketch solver. First, we'll start off with a set of mirrored curves here. As you can see, we have some mirrored curves about that y-axis, of course, and they have a persistent mirrored condition applied to them. If I were to go ahead and grab one of the mirrored curves and drag that over to the y-axis, the curves become collinear, and now we have collinear conditions or relations that were found. All I have to do is go ahead and click on one of those curves and relax the relations. So I can relax those relations, whether that's coincident or collinear in this case. And then we can pull the mirrored curves back apart. The software recognizes those are still mirrored curves, and you can see that relationship is maintained. Jumping over to the next item here, we'll look at some profile curves on this design here, and we're going to offset that profile 70 millimeters. If I go back into this offset dimension here, and I set that back to 0, those curves will now be, the offset curves will now be on top of the original curves. Before this enhancement, what would happen is that the coincident curves, we would have coincident conditions at the endpoints, we would have collinear conditions here, and it would not be easy to make those modifications. Now we can easily go back in with the enhancement, edit the offset dimension, and get those curves to offset very nicely, and it releases those coincident conditions inside of our sketch solver. Next up, we're going to talk about a new functionality inside the sketch solver. It's called mechanism mode. So in NX2206, this was introduced, and it's a mechanism mode that you enter. And what this is going to do is it's going to allow you to get free movement inside your sketch without locking curves to a given axis, whether that's the Y or the X axis. This is a user-requested enhancement for manual control when animating a sketch with the ability to infer persistent relations here. So the new mechanism mode supports movement of your curves into a different design position. It's also enhanced to support skeleton sketches that drive geometry in a part or multiple components of an assembly through linking. This gives you the ability to convert found relations to persistent relations upon entering this mode. You can also use this with work regions inside of the sketch solver. We can use the mechanism mode with your work region command to support creating persistent relations only within a portion of a sketch if you'd like to do that. It also disables relation finding when the mechanism mode is active inside the solver. By disabling our relation finding, the new mechanism mode is going to permit free movement inside the sketch without locking curves to an axis here. The user needs to create all future relations while inside the mechanism mode. So we'll take a quick look at the new sketch, new mechanism mode inside the NX software. Here you can see we have a basic schematic set up inside of our sketch solver. In this example, we're going to go ahead and begin to make some changes to this design. In this case, we're going to double click on this angle dimension, grab one of the handles, and start to interact with the handle. As I drag this handle all the way around, you can see the adjustments being made inside my design and the direct relationship between the different curves. If I choose to stop my motion near one of the axes, in this case the x-axis, the sketch solver creates a collinear found relation here. Once that collinear found relation is found, it's not going to allow us to interact with that dimension and move it away from that condition. So if I double click on that dimension one more time and I try and move that, you can see my geometry is not going to be able to move from that condition. We can use a new mechanism mode here to override these conditions by permitting free movement without locking curves to your axes. If we go into the options dropdown, you'll see the new mechanism mode is available here. We'll go ahead and activate that. Once we enter the mechanism mode here, the software is going to tell the user that all of our different relations will be converted over to persistent types of relations. We can choose yes or no here. If I choose yes, all of my found relations inside the sketch solver will be converted to a persistent type relation. As you can see, once we do that, the relation finder settings will also be deactivated here. And that's because the software is not going to be finding relations at this point going forward. With the mechanism mode activated, all of our relations are going to be treated as persistent, and we can now modify the angle dimension and increase the angle, and the sketch solver no longer creates that found collinear relation between our linear curves and the axes here. If I go back in and double click on that and edit that dimension, once again you can see I can move the geometry freely without those types of found relations being found by the solver. This mechanism mode is going to allow for greater flexibility inside your different sketch solver setups here when you want to build these types of schematics or layouts and interact freely with the geometry inside the sketch solver without it finding those relations. Next, we'll take a look at some feature modeling enhancements inside your NX software. We'll take a look at the following categories: manual thread input options, history free mode, which returns to the software, the Revolve Outline, which is a new capability, design preference dialog settings, such as search functions that have been added here, selection program enhancements, Revolve enhancement, symmetric value, some pattern enhancements, patterning relative to a path, and then we'll also take a look at one final feature here, which is pattern body. This is a new functionality inside the software. So let's go ahead and begin taking a look at these feature modeling enhancements. All right, the first one we'll take a look at here is the manual thread input option, introduced in NX 2007. Our manual thread input option is going to enable you to create a non-standard thread size when you're creating those threads on your holes with the thread feature. You can still go ahead and use the custom thread sizes by setting those up in your NX thread standard XML file, or you can now directly enter those inside the thread form with the manual mode here. So this is a customer requested capability. It has returned the manual thread input during symbolic and detail thread creation here. Users do not need to modify the thread XML to add standard threads. You can now go in, select the manual option, and enter your custom parameters for your threads inside the thread dialog box. When you're using thread table with radial and gauge set to custom, you can also enter a custom tap drill size, and you can go ahead and enter that at the time of creation. This is also now supporting renew of legacy manual threads using renew feature command as well. All right, jumping into a demo here. We'll take a look at adding some manual threads to our hole features. The first thing we want to do is go up to the More drop down here and go into the Thread command. Once we open up that Thread dialog box, we'll be able to go ahead and add some manual threads to some holes on our parts. On the Input drop down, you'll see an option for Manual Thread Input now. Once we activate that, we'll go ahead and select our hole here to apply our thread to. After setting up some parameters here for our start and our vector direction for the threads, we can go right back over to the dialog box and enter some parameters here to customize the thread size. After entering a few of those manual inputs, we'll select OK and create the thread feature on our hole. Jumping over to our next hole, we want to go back into our thread feature command here. And with this option, we're going to go ahead and choose the thread table this time. Select the hole to add the thread to. And down below, you'll see with the radial and gauge settings, we can go into a custom setting here. Once we activate the custom setting, we can customize the tap drill diameter sizes here. After applying our custom size, we'll go ahead and select OK to add the thread to the hole. All right, jumping into our next topic here, we'll be looking at the history free mode that has been brought back to the software, and this is brought back in NX 2007. The history free mode is back for quick conceptual design work and protection of intellectual property inside your parts. This includes capabilities such as giving you the capability to quickly remove features from your part files. This is good for doing quick conceptual design work if you want to strip out all the features from the part and then use synchronous technology to make some quick modifications. Once you've made those quick modifications, you can go off to a meeting and review the part with your design team. Also, a nice capability here is with the ability to remove or strip those features out of the part, as you can share the part file with your customer or vendor. They can use a native .prt file format, open that up in NX, but all of the features have been stripped out, so they just have a single dumb body inside of that part file. When you activate history free mode, any features that are already existing inside that part will be removed from the model. Now, when you do activate history free mode, as you create new features inside the part file, it will not be saving features inside the part navigator. You can still use all your standard modeling capabilities, all your different model creation processes, but it's not going to create a feature inside the part navigator. When activating history free, an information message is going to be displayed to inform you that you are changing the model to history free mode, and it will be removing all the parameters from the features inside your model. You have two options here, yes or no, if you want to continue. If you say yes, it is going to strip out all the features from this part. I highly recommend using a file save as motion first before you do this. So once you do this, it's going to strip out all the features. You do not want to save over the current revision. You maybe want to do a save as and save the next revision, or just save a different version of the file before doing this. All right, next feature we'll look at is a new feature inside the software. This is called Revolve Outline. This was introduced in NX 2007. What Revolve Outline is going to give you the capability to do is to create these fully associative 2D outlines of these complicated spun shapes in a single step. So you can create these 2D outlines or envelopes by combining axisymmetric or non-axisymmetric, for example, turbine blades, holes, etc., features onto a single plane. This does support the selection of a body or multiple bodies inside of the same part file. It also allows the user to exclude faces from the part and not have those shown inside the revolved outline. All right, jumping into a quick demo of Revolve Outline. Revolve Outline is a new operation inside the software. It is fully associative, and that can be found under the Curve tab. It is a derived operation, so derived, more dropdown, and then Revolve Outline feature is available there on the dropdown. Once you open up the Revolve Outline feature, we'll select the body and then select OK. We'll take a cross-sectional cut through this part. We'll trim away half of this body, and then we'll be able to see our revolved profile on the plane. Next, we'll take a look at creating another revolve outline. So we'll click on our body here, select OK. And in this particular example, you're going to see that we do have some holes that are going through that body. When we look at our revolved outline, we have a couple of holes here we might want to omit or exclude from the revolved outline profile. We can do that very easily by going back into the revolve outline, selecting the exclusion face category, pick on the face, and select OK. That face has now been excluded from the profile. Additionally, we have multiple bodies we can use with the Revolve Outline functionality here. So we'll click on Revolve Outline. We can select or box around all the bodies inside the part file. And then we can select the axis of revolution and select OK here to complete the Revolve Outline command. Once we trim away half this body, we'll take a look at our overall profile or envelope. Nice thing about Revolve Outline, this is fully associative, so if you make a change to one of those bodies, or wavelink in, or replace the wavelink body into the part file here, it's going to update the Revolve Outline, and you're going to have your new profile being presented there with that Revolve Outline feature. Our next topic here, design preference dialog updates. We have search functions that have been added here. This is introduced in NX 2007. The modeling and sketch preference dialogs have now been converted to block-based dialogs, which enables design preferences to be found with the search option. Easily, we can find design preferences, and we can find those inside the global search, or we can actually use the search function within the modeling sketch preferences dialog also. Next topic here, selection program enhancements. This was added in NX 2206. The selection program enables more robust feature updates inside your models. We did share the selection program enhancements back when they first were introduced in NX 1980. Now there are some enhancements or improvements to that functionality inside of NX 2206. The proximity filters can reference bodies in addition to datums to find seed objects for feature input and allow for more robust feature updates. Additional selection intent options are available in the adjacent face selection rules, for example, feature faces or blend faces. So jumping into a demonstration of the enhancements here with your selection program. Here we have a main body, we have a fin that comes off of that main body, and these are wave-linked bodies inside of this part. So we're going to add a blend to the intersection edge. Once we've replaced one of the linked bodies here with a different body, you can see our edge blend is going to fail. After the original wavelength body is replaced with the new body, the edge blend is going to fail because it can't reference the original intersection edge there. We're going to go ahead and turn on the datum plane here inside this part file. And when we create the edge blend this time, we're going to go in and use the selection program to define a new rule. Once we turn on the selection program, we can go ahead and use body edges here for our selection intent. We can set our criterion to intersected by, so anything that intersects the body edges, in this case, we're going to choose the datum plane. Once we choose the datum plane, you can see the edges that are selected because those are being intersected by the datum plane on that body. Or we can go ahead and use a sheet body as the intersection object here. So in this case, anything or any edge that is intersected by that sheet body will be selected here with our selection program. Using the defined selection program, NX selects both the edges that are intersected by that sheet body. Next thing we'll look at here is the Revolve feature, new symmetric value limit option. So this was introduced in NX 2206. Now when creating your Revolve features inside the software, there's a new symmetric value limit option to create an angle symmetric about the section that is being revolved. All you have to do is go into the limit settings, hit the drop down and choose the symmetric value option here. Once you do that, dragging the handles will affect both sides symmetrically inside of your design. Our next feature enhancement we'll look at here is called Pattern Enhancements, Pattern Along. Introduced in NX 2206, Pattern Along can create a simple patterning of components or geometry relative to a path. With the Pattern Along option in the Pattern dialog box, you can associatively position objects relative to a path at defined point locations here. The pattern service has been enhanced so all pattern tools can leverage Pattern Along with point selection intents. Pattern Along can associatively reference feature points along a path. Components reference the Pattern Along feature to position the components along the path with the proper orientation. All right, so we'll take a look at a quick demonstration of the Pattern Enhancements, Pattern Along functionality inside the software. For this demonstration, the skier on the studio spline here, that is a component inside this part. First, we'll create a point set on the spline, and we use the equal arc length method here. This will create points at equal intervals along that spline. Once we create the pattern, next we'll create a pattern geometry feature, and we'll create a pattern of the datum coordinate system inside this part. This datum coordinate system was used to orient the coordinate or the component when it was placed inside this part. So when we do the patterning of the datum coordinate system, we're going to specify the points. We're going to be referencing the pattern of points here, that point set item number 4 inside of our part navigator, and creating datum coordinate systems at those points. Now we use the pattern component operation to pattern the skier, which is the component inside of our assembly. Once we select the component, we'll select the pattern. We'll reference the datum coordinate system pattern. So click on that pattern, and then we'll select the point at the base of our component. Once we select OK here, it's going to pattern the component and set up each one of those component instances at the same location as the datum coordinate systems. If we make a modification to the studio spline, we can see our skiers update. Once we increase the number of points in our point set, you can see our skiers will update accordingly as well. So we use 3 different types of patterns to achieve this capability. Jumping into our next topic here, we'll be looking at the pattern body functionality. This is a new functionality inside NX2206. So improvements have been made to Boolean performance for large numbers of pattern tools. The new pattern body command generates a combined patterned output body from an input cell body here. A couple of requirements here. The input is a single body. The pattern methods we can use are linear, circular, or helical. This is going to leverage chunky Boolean methodology to improve performance inside your part. The requirements here, the pattern bodies must have coincident matching faces. This is going to improve performance by up to 75% on average with these types of complex bodies when you use the pattern body operation. So jumping into a quick demonstration of pattern body here. We'll be starting out with the single cell here. For this filter we're going to be designing. If we go into the base group, the more drop down, and inside the copy group, you will see the pattern body feature. Once we select the pattern body feature, we can go ahead and begin creating the pattern of our cell here. First thing you want to do is select the body to pattern. So in this case, we'll pick our cell. Once we select the cell, we can specify the pattern definition, whether that's linear, circular, or helical. So if we hit the drop down, we'll choose to create a circular pattern here for the base. Specify our vector or axis of rotation here, and then select OK to create the pattern for our base of our filter here. Once we have our base created, we can create an additional pattern. So we'll go right back into the pattern body operation, select the body, which is the base here, and we'll set this to a linear type pattern, specify the vector to pattern along, and in the count will be 30 this time. So once we pick on the vector direction here, we can create those 30 instances along that distance. Now this feature is being created in approximately 1 minute and 45 seconds. To save time, we did speed that up. The nice thing about this is we can go ahead and create or edit some of the variables in this. So we have a tube that was in the original cell, and we can modify the diameter size here of that tube. If we change that from 12.5 to 15, this will take approximately 1 minute and 25 seconds to update after making that change. As you can see, this is a much quicker process than if I were to have to try and create this with all these individual different holes and a series of different types of patterns. So there will be a huge time savings when you use the pattern body functionality for these types of complex designs. All right, the next feature we're going to be looking at here is the Move Object enhancement. This was added in NX2206 inside the software. And this enhancement is going to allow the user to move objects and have an improved user experience and more efficient operations. These improvements address a high number of enhancement requests from the customers regarding the Move Object feature. There is a new setting inside the dialog box that allows for updating of depending features here when the parent feature is moved inside the design. It also retains selection, dynamic manipulator orientation, and all parameters inside a dialog memory. There's an instant model update instead of just a preview now. It also allows combined usage of different motion types, very similar to the move component command. There is also the capability to allow snapping on preview entities. Implemented a local undo inside the move object command. The general user experience here is greatly improved with these enhancements. Also, there's an improved preview performance, so when you are moving that geometry, it will be more efficient and there'll be an improved performance there inside the software. And finally, there are also enhancements to the handle controls when you're working with the move functionality here. Jumping into a quick demonstration. So inside our feature modeling enhancement, move object enhancements, we'll go up to our tools tab. Once we get up to the tools tab, we'll select on the move object command here. Now in this particular design, we have an exterior shell with a couple of interior rib features. Those interior rib features were created with the curve features that you can see here in the display. We're going to activate the update depending feature options in the settings. Once we activate those, you're telling the software that we want to go ahead and move all of our depending features when we move, in this case, the curve. So if I select on that curve to move, I can use my motion set to dynamic here and interact with the handles to move that geometry. Once we move that geometry, the depending feature, which is the rib feature, is going to move and update the curve during this operation. NX recognizes the parent relationship here with that child, which is the rib, and it's going to move that accordingly. As you can see, the preview updates very nicely and is much more efficient. Now we can go into our transformation options here for our motion category, and we can select a distance motion instead. All we have to do is pick on a vector direction to move the object along, grab the handle, and move that object. We can also change the angle here. So I'm going to specify the x-axis as my axis of rotation. Then we'll select the object and then set the angle of rotation. Once we rotate this at an angle of 355 degrees, you can see the tops of those ribs have changed on a 5-degree angle here. There's also an undo command that you can take advantage of while you're inside the move dialog. And that is the move object enhancements. All right, so that's going to conclude the presentation. Thank you for watching. Once again, here's my contact information. And coming up next will be my colleague John Vincent presenting what's new in NX 2007 2206 CAM related items.